Hello, welcome back, everybody. Continuing this one's gonna be pretty short. This is just about Ohm's law applications. Again, as always, please leave a like, subscribe, and we will keep on going. And as always, if you'd love to support, there are links in the description that you can do so. It really helps me out. So, with the application of Ohm's law, I'm just gonna this is the equation this professor decided to give us, talking about all of this stuff. Essentially, a voltage source with resistors both in series as well as parallel. I'm not gonna even try to pretend this is a college level physics type equation, and an equation of this depth, I have not solved equations like this in a very, very long time. So I'm not even going to try to fully walk through how he did this equation, but I'm going to go over the basic principles that are all involved in this. So the main principle behind all of this is talking about resistors in series versus them being in parallel. All right. When we have resistors in series is referring to when they're one after another. So here's our current, we have a resistor, and then like that. So they are in a series from one another. The current is the same through all of the resistors. The total resistance, how we calculate, okay, how much actual resistance is there from the beginning to the end, is we literally just add up the resistances. So we'll say, okay, this, whatever this resistance is, let's say this resistance is 3. This resistance is 4. We'll do 3 plus 4 is 7. So 7 ohms worth of resistance in this specific circuit, in this specific chunk that we are measuring. We can take that information. So if we know the total resistance, and we can take that and we can actually plug it in to Ohm's law. So Ohm's law, I equals V over R, current equals voltage over resistance. We can rework this equation a couple of different ways. So if we multiply the resistance over the other side, this is our voltage. For N is referring to how many different chunks of resistance there are, or how many different things that there are all through. It can be voltage 1, voltage 2, voltage 3, or so on. So we can do this equation multiple times for each individual resistor. All right, which is actually, I'm pretty sure, what is going on here. This is honestly just such a mess to try to decipher that I didn't feel up to the task of trying to break it all down. Anyways, so we can do this with, so for example, this is this would be our number 1, this is number 2. We can take those values, we can plug them in, we can figure out exactly what the voltage is, we can figure out what the current is, we can figure out what the resistance is, depending on what other information that we are given. And then once we do that equation at each of these points, we can figure out the total voltage across the whole series by literally just adding up all the voltage at each of those points. And that gets us resistors in series. Resistors in parallel, very, very similar process. Only main difference is that the voltage is the same across all the resistors. Then the total resistance is found using what's called the reciprocal formula. Resistors in parallel, it looks like this, where we have, so these wires break off and the resistors are parallel and they come back together and keep going. So we use this equation, 1 over the R total equals 1 over R1 plus 1 over R2, and so on and so forth, depending on how many resistors are contained within whatever we're looking at. Again, Ohm's law, We talk about the current through each resistor depends on its resistance and is then calculated using Ohm's law. So this you can kind of see the difference. So the current is the same through all the resistors. So if we have with resistors in series, the current is the same through all of the resistors. So we can use whatever value the current, whatever the value is for the current, most likely to be given to us. We can plug that in, and because it's constant, let's see, did we get a current here? The voltage source with R is equal to 0 ohms. Okay. Okay, we weren't given any of the specific currents. However, we're given enough information in this problem with the resistors where we can take these values and go and plug those in across in order to solve for all the different. It's a multi-step kind of algebraic type question, which I don't want to go through that whole thing right now. So yeah. So with resistors in series, the current's the same all the way through. Resistors in parallel, the voltage is the same all the way through. So we're just solving for different variables. So we use Ohm's law slightly differently. And then total current is the sum of the currents through all of the resistors. It gives us the total sum. So kind of a general reminder, in series circuits, the voltage divides among the resistors, but the current remains constant. In parallel circuits, the voltage remains constant across each resistor, but the current divides based on the resistance of each branch. Okay, so not the full and total breakdown, however, because it gives you a little bit of a better idea of Ohm's law. And if you want to tackle this, I would recommend just copy paste this image into ChatGPT, and give it the information and see and ask it to walk you through it step by step. Hopefully, he's not requiring you to do questions of this magnitude, or whoever the professor is. They're not requiring you to do questions of this magnitude, because we're really not going to see. Again, you're not going to see this pop up again anywhere else in this course. So yeah, thanks so much for watching. Good luck studying and have a wonderful day.